According to the National Electrical Code, Article 517, Section 517.10b, in work pits, all lighting fixtures must be listed for Class 1, Division 2 hazardous classified locations. The NEC defines Class 1, Division 2 hazardous classified locations as vaults, storage tanks, and rooms containing volatile, flammable liquids or vapors or flammable gases in quantities sufficient to produce an ignitable mixture. This means that lighting fixtures located in a work pit in a garage area where flammable vapors may be present must be designed to prevent the ignition of flammable vapors in the event of a spark or other ignition source. The requirement for conduit seal-offs to prevent vapors from traveling applies to all conduits in the pit, regardless of whether they carry lighting or electrical circuits. Ground fault circuit interrupters are not explicitly required for lighting circuits in work pits, but they are generally recommended as an added layer of protection against electrical shocks. The code does not specifically address the placement of receptacles below grade in work pits. However, receptacles located in wet or damp locations should be listed for that use and protected by ground fault circuit interrupters. Therefore, firstly, ensure that all lighting fixtures within the work pit are specifically listed for Class 1, Division 2 hazardous locations. This certification indicates that the fixtures are designed and tested to prevent ignition of flammable substances that might be present in the atmosphere of the pit. Secondly, implement conduit seal-offs on all conduits entering or exiting the work pit. These seal-offs are crucial in preventing the migration of flammable vapors or gases from the pit into other areas of the facility. Thirdly, although not mandated for lighting circuits, consider incorporating ground fault circuit interrupters for an extra layer of safety. Ground fault circuit interrupters can help protect personnel from electrical shocks by quickly cutting off power in the event of a ground fault. Fourthly, pay close attention to the placement and type of electrical receptacles used in the work pit area. If receptacles are positioned below grade, ensure they are specifically designed for wet or damp locations and are always ground fault circuit interrupter protected to minimize the risk of electrical hazards. In summary, the key elements to focus on are using appropriately rated lighting fixtures, employing effective conduit seal-offs, considering the addition of ground fault circuit interrupters, and carefully managing the placement and protection of electrical receptacles. By adhering to these guidelines, a safer working environment can be established within the garage work pit. Class 1, Division 2 locations are areas where volatile flammable liquids or gases are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. This classification also includes areas where ignitable concentrations of flammable gases or vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or that are adjacent to Class 1, Division 1 locations, and to which ignitable concentrations of flammable gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. In simpler terms, a Class 1, Division 2 location is a place where flammable materials are not typically present in the air in explosive concentrations under normal operating conditions. However, these materials might escape under abnormal conditions like a leak or spill. The electrical equipment used in these locations must be designed to prevent ignition of the flammable substances. The NEC provides detailed guidelines for electrical installations and hazardous locations to minimize the risk of explosions and fires. It's important to consult the latest version of the NEC and any applicable local codes to ensure compliance. The intent of requiring seal-offs and conduits in hazardous locations is to prevent the propagation of explosions from one area to another through the conduit system. Seal-offs are typically installed at the boundaries of hazardous locations, such as where a conduit enters or exits a Class 1, Division 1 or Division 2 area. The seal-off fitting is filled with a special sealing compound that is designed to prevent the passage of gases, vapors, and flames. This helps to contain any explosion that might occur within the conduit system and prevent it from spreading to other areas. Seal-offs also help to limit the amount of flammable vapor or gas that can accumulate within the conduit system, reducing the risk of an explosion. The NEC specifies the requirements for seal-offs in hazardous locations, including the types of fittings and sealing compounds that are permitted, the location of seal-offs, and the procedures for installing them. It is crucial to follow these requirements carefully to ensure the safety of the electrical installation. Here are some key considerations for seal-offs. Firstly, location. Seal-offs should be installed at the boundaries of hazardous locations, such as where a conduit enters or exits a Class 1, Division 1 or Division 2 area. Secondly, type of fitting. The seal-off fitting must be listed for use in hazardous locations and must be appropriate for the type of conduit being used. Thirdly, sealing compound. The sealing compound must be compatible with the flammable substances present in the hazardous location and must be installed according to the manufacturer's instructions. Fourthly, installation. The seal-off must be installed correctly to ensure that it effectively prevents the passage of gases, vapors, and flames. Fifthly, inspection. Seal-offs should be inspected regularly to ensure that they are in good condition and that the sealing compound is intact. In addition to these key considerations, it is also important to follow any other applicable requirements in the NEC and local codes. Ground fault circuit interrupters are designed to protect people from electrical shock. They work by monitoring the current flowing in a circuit and detecting any imbalance between the outgoing and returning current. If there is a difference of 5 mA or more, the ground fault circuit interrupter will quickly trip, cutting off the power to the circuit. Ground fault circuit interrupters are commonly used in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. They are also required by the NEC in certain locations, such as in construction sites and in healthcare facilities. Ground fault circuit interrupters are available in several different types. Firstly, receptacle type. These ground fault circuit interrupters are installed in place of a standard electrical receptacle and provide ground fault protection for that outlet. Secondly, circuit breaker type. These ground fault circuit interrupters are installed in the electrical panel and provide ground fault protection for an entire circuit. Thirdly, portable type. These ground fault circuit interrupters are designed to be plugged into a standard electrical outlet and provide ground fault protection for any uppercutter plugged into the ground fault circuit interrupter. Ground fault circuit interrupters are an important safety device that can help to prevent electrical shock. If you are not sure whether you need a ground fault circuit interrupter in a particular location, consult a qualified electrician. The NEC provides specific guidelines for the installation of electrical receptacles in various locations to ensure safety and prevent electrical hazards. The requirements vary depending on the environment, such as wet, damp, or dry locations, and the intended use of the receptacle. Here are some general guidelines for receptacle installation. Firstly, location. Receptacles should be located in accessible locations and should not be installed in hazardous locations unless they are specifically designed for that use. Secondly, height. The NEC specifies minimum and maximum heights for receptacles in certain locations, such as in kitchens and bathrooms. Thirdly, grounding. All receptacles must be properly grounded to provide a safe path for fault current. Fourthly, ground fault circuit interrupter protection. Ground fault circuit interrupters protection is required for receptacles in certain locations, such as bathrooms, kitchens, and outdoor locations. Fifthly, weather resistance. Receptacles installed in wet or damp locations must be weather resistant and must be protected by a weatherproof enclosure. Sixthly, tamper resistance. Tamper-resistant receptacles are required in dwelling units to protect children from electrical shock. Seventhly, dedicated circuits. Dedicated circuits may be required for certain appliances, such as refrigerators and air conditioners. In addition to these general guidelines, the NEC also provides specific requirements for receptacle installation in various other locations, such as healthcare facilities, industrial facilities, and recreational vehicle parks. It is important to consult the latest version of the NEC and any applicable local codes to ensure compliance. When working in a garage work pit, it's essential to have adequate lighting to ensure safety and visibility. The NEC requires that lighting in these areas be suitable for the specific conditions present, including the potential for flammable vapors or other hazardous materials. Here's a breakdown of the key considerations. Firstly, hazardous location rating. If the work pit is considered a hazardous location due to the presence of flammable vapors, the lighting fixtures must be listed for use in such locations. This typically means they should be rated for Class 1, Division 2 environments, as discussed earlier. Secondly, illumination levels. Ensure that the lighting provides sufficient illumination for the tasks being performed in the work pit. The specific illumination levels required may vary depending on the type of work being done, but generally, the lighting should be bright enough to allow workers to see clearly and avoid hazards. Thirdly, fixture type. Choose lighting fixtures that are durable and resistant to damage from impacts, moisture, and other environmental factors. LED fixtures are often a good choice due to their energy efficiency, long lifespan, and durability. Fourthly, placement. Position the lighting fixtures to provide even illumination throughout the work pit, minimizing shadows and glare. Consider using multiple fixtures to achieve this, and ensure that they are positioned so that they don't obstruct access to equipment or create trip hazards. Fifthly, wiring and installation. All wiring and electrical connections must be installed in accordance with the NEC and any applicable local codes. Use appropriate wiring methods and ensure that all connections are properly made and protected. Sixthly, maintenance. Regularly inspect and maintain the lighting fixtures to ensure that they are functioning properly. Replace any damaged or malfunctioning fixtures promptly to avoid hazards. In addition to these considerations, it's also important to be aware of any other specific requirements or recommendations from local authorities or industry standards. By following these guidelines, you can ensure that the lighting in your garage work pit is safe, effective, and compliant with all applicable regulations. It's important to consult the specific requirements of the NEC as well as any local codes or regulations that may apply to your particular situation. The NEC is updated regularly, so it's crucial to stay informed of the latest changes and interpretations. Additionally, it's always a good idea to consult with a qualified electrical inspector or engineer to ensure that your electrical installations are safe and compliant. These professionals can provide valuable guidance and expertise, helping you to avoid costly mistakes and ensure the safety of your employees and property. Remember, electrical safety is paramount, and it's always better to err on the side of caution when it comes to electrical installations. By following the NEC and other applicable codes and standards, you can help to create a safe and productive work environment. In addition to the technical aspects of electrical installations, it's also important to consider the human factors involved. Make sure that your employees are properly trained in electrical safety procedures and that they understand the potential hazards associated with working around electricity. Provide them with the necessary personal protective equipment, such as safety glasses, gloves, and insulated tools, and ensure that they use it properly. Regularly review electrical safety procedures with your employees and reinforce the importance of following them. By creating a culture of safety in your workplace, you can help to prevent accidents and injuries and ensure the well-being of your employees. The NEC is a comprehensive set of standards that covers a wide range of electrical installations, from residential wiring to industrial power systems. It's essential to have a thorough understanding of the NEC to ensure that your electrical installations are safe and compliant. Consider taking courses or attending seminars on the NEC to stay up to date on the latest changes and interpretations. There are also numerous online resources available that can provide valuable information and guidance. In addition to the NEC, there are other codes and standards that may apply to your electrical installations depending on your location and the type of facility. These may include local building codes, fire codes, and industry-specific standards. It's important to be aware of all applicable codes and standards and to ensure that your electrical installations comply with them. The enforcement of electrical codes and standards is typically the responsibility of local authorities, such as building inspectors and fire marshals. These officials may conduct inspections of your electrical installations to ensure that they meet the requirements of the applicable codes and standards. If violations are found, you may be required to make corrections or face penalties. It's important to cooperate with these officials and to address any violations promptly. The NEC is not a static document, it is updated every 3 years to reflect changes in technology, industry practices, and safety concerns. It's essential to stay informed of the latest changes to the NEC to ensure that your electrical installations remain compliant. The NEC is developed by the National Fire Protection Association, a non-profit organization that is dedicated to reducing the risk of fire and other hazards. The NEC is widely adopted throughout the United States and is considered the gold standard for electrical safety. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It also includes specific requirements for different types of occupancies, such as residential, commercial, and industrial facilities. The NEC is a valuable resource for electricians, engineers, contractors, and anyone else involved in electrical installations. It provides clear and concise guidance on how to design, install, and maintain safe and reliable electrical systems. In addition to the NEC, there are other resources available that can help you with your electrical installations. These include technical manuals, training programs, and online forums. It's important to take advantage of these resources to enhance your knowledge and skills. Electrical work can be dangerous, and it's important to take precautions to protect yourself from injury. Always de-energize electrical circuits before working on them and use appropriate personal protective equipment. If you're not comfortable working with electricity, hire a qualified electrician to do the work for you. The NEC is not intended to be a substitute for sound engineering judgment. It's important to consider the specific circumstances of each installation and to apply your knowledge and experience to ensure that the electrical system is safe and reliable. The NEC is a living document that is constantly evolving to meet the changing needs of the electrical industry. By staying informed of the latest changes and interpretations, you can help to ensure that your electrical installations are safe, compliant, and reliable.